Hello everyone, I hope you all are doing good at your places. So welcome guys in the world of physics with force and motion. We have gone through a number of concepts related to our force and motion up till now. But now we are going to interrelate both the concepts. That means we are going to study how force can cause motion and how a motion can result to a force. Okay, and we will going to find out the different relationship between them. See guys, when I hope you all are aware, I hope you all are familiar with a particular swing which is being seen to you all. Okay, so at one part there is a girl, or you can say a small kid, who is just swinging, and he is just supported by a man. The same man is giving equal force to another man which is a bit, you can say, having a larger mass. So there you go guys. Suppose this girl is having a mass m1, this is having a mass m1, and that's having a mass m2. So guys, I can say that mass m1 is less than m2. I should say very less than m2. Okay, there is a huge difference between the mass. So the person who is applying an equal force, equal force on both these swings, the result is that the girl with the same force is having a larger acceleration. Force is resulting in a better motion rather than force applied on the mass m2, that is a heavier body. That means if we apply equal force on two objects that are possessing different masses, that will going to result in two different acceleration caused. Okay, so the same force has causes an acceleration which is higher, that is a1. Okay, so acceleration caused in mass m1 is very higher than acceleration caused in a2. Can you say that? Or I should explain it later again. See, there are two bodies. First is a pink and blue dress wearing girl, or a baby, you can say a small girl, which is having a less mass. Then there is another boy who is having a larger mass, that is mass m2. They both are swinging, and a person, uncle, is just help them in swinging out. And while that swinging, the person is applying equal force on both these swings. You can see that he is applying equal force on both these swings, but the result is that the girl having lesser mass is possessing a larger acceleration, and the boy is having a, sorry, girl having a lesser mass, smaller mass, is having a larger acceleration, and the boy having a larger mass is having a small acceleration. Okay, so what does that mean? That actually means what is a Newton's second law. Okay, so guys, if we notice, according to my Newton's second law of acceleration, he always say that the acceleration caused by a body is directly proportional to the net force which is applied up in the body, which will be, yes, the net acceleration. If we talk about acceleration, then we can say the acceleration caused in a body is of an object depends on its mass as well as on the force applied to it. Okay, it will dependent on both. So acceleration caused in the swing, you can say it is dependent on two things, that is mass and second is the acceleration. So we can find out the value of force applied on both of them, and if I say, if I applied the force, then what? Then I can say the force applied, the net force acting on the object, causes the object to accelerate in the direction of net force. What does the mean of net force? Firstly, I have told you what are the two different types of force. Force is of two types: balanced force and unbalanced. When we talk about balanced force is of no use if we actually consider a motion. If we need a body to possess a motion, then there should not be any kind of, how can you guess it? there should not be any kind of motion. If both the forces applied on it are balanced, that means it won't result to any kind of resultant force. And if there is no resultant force, there is no direction of motion. Actually, there is no motion. Okay, so if we need to consider the motion, what do we need to do? We need to find a resultant force. Okay, so in such cases, we can say that what kind of uh, force is required by us to cause a motion. To cause a motion, it is mandatory to have an unbalanced force. And how we can generate an unbalanced force? Yes, how can we generate an unbalanced force? An unbalanced force will going to result in some kind of motion. Just like an example, if you are having a box at this place, that's a box which is having a mass m, and there is a force that is of 10 Newton, and there is another force which is of 10 Newton. So what will be the result? Both the forces of 10 Newton are applied on this body of mass m. What will be the result? Result is there is no motion in the body. Body will stay here at rest. But if my mood got changed and across the same body of mass m, I have applied a 5 Newton force at this place and 10 Newton force at this place. Then after some time I notice that my mass has been displaced up till this much of distance. Alright, so this is what? This is first thing that we need to understand the Newton's second law of motion, that for a motion to occur, it is mandatory to possess an unbalanced force. All right. And now the next concept, the unbalanced force caused in such kind of situation, the net force acting on the object causes the object to accelerate. Whatever the unbalanced force is applied, the net resultant of that force will going to result in a acceleration or motion. Motion is there, so definitely velocity will going to increase if a body is at rest. See, if a body is at rest at this point, at 0, okay, and if it is moving with some velocity at to this point, then I can say that it will possess some kind of acceleration. Obviously, velocity has been, initial velocity was u and final velocity was v. So u is 0 here, v will be the final velocity. So the v minus u upon t, that will be the acceleration. So yes, it is possessing an acceleration in the direction of that net force. Then that acceleration, it is mandatory to be possessed in the direction of that resultant. Whatever is the larger force, that will be the resultant force. So the motion, the force acting on an object causes the object to accelerate in the direction of net force applied. All right. And also we can say that the acceleration of an object equals the net force divided by the mass. And as you can see in the following diagram, we can say that the acceleration caused in the swing you have seen right now is directly proportional to the force applied. Yes, the acceleration caused in a swing is directly proportional to the force applied by the uncle. Okay, and it should be inversely proportional to the mass of the people, or mass of the children, or mass of the girl, or a heavy boy which is just sitting on that swing. Okay, so we can say that acceleration is directly proportional to force, acceleration is inversely proportional to mass. Then I can say that acceleration is equals to, I can mark, acceleration is equals to mass into, force upon mass. Resultant force, net force upon mass, we can say that if there are multiple forces, but if not, then that will also be okay. You can see the variation in this. Here, the acceleration has reached to 1. As acceleration increases to 1, force increases, force was 1. Then if we keep constant, see, initially, I wish I can pause it. Force and acceleration, you can see that they are directly proportional. If acceleration is increasing, force is increasing. If acceleration is decreasing, force is decreasing. If acceleration is increasing, mass is decreasing. See, 1 upon 2 and 1 2. Okay, so we can say that if my acceleration is increasing, my force will increase. If my acceleration is increased, then my mass will decrease, and vice versa. All right, so this is my Newton's second law of motion, and we can say that for a Newton's second law of motion, we can pick up number of examples. Yes, best example is you just pick up a cotton ball and just go to your terrace and a baseball. Okay, in one hand there is a baseball, in another hand there is a cotton ball. Throw them both from your hands from the terrace and notice at what time they both will reach. You will notice the baseball will reach earlier, the cotton ball will reach at lesser time, although the acceleration is applied on them is both is same. Then how we can say that what is going on in it? The acceleration is applied by the gravity is same, but the force, suppose that's a cotton ball and that's a baseball. Let's see, that's B. C for cotton ball, B for baseball. If acceleration due to gravity, we talk about G is constant for both. But as cotton ball is having a less mass as comparable to baseball, okay, in fact, I should say very less. Very less mass than the baseball. Then equivalent force, overall force of mcg is very less than mvg. So, if this force is lesser, the acceleration caused in it will be lesser than acceleration in a baseball. So this is all how you can calculate a different kind of things. You can say that because of their different masses of cotton ball and baseball, the cotton ball will reach later while baseball will reach faster. Acceleration of an object depend on its mass as well as on its force applied on it. Okay, then we can say that are they all connected? Yes, they all are connected. How? By the relation of Newton's second law. All right. So you can see that there is a force applied on pulling on the wagon as hard as it is possible. Suppose I have applied a force on it and both the forces are same. I can say that my first condition is force applied on both the wagon is same. Force applied on wagon is same. All right. So if force is same, then I can say that how can I find the acceleration? This is A1, okay, above 1. I am marking it here. A1. Oh, that's A1. F upon small m and A2 F upon capital M. Okay, so if we notice both the forces are same, both the forces are same, but you can say that the mass of A body, let's just imagine the mass of A, that is small mass, is very less than capital mass. Then what will be the effect? I can say my acceleration will be equals to F upon M. So F is constant, we can leave the constant. So A is directly proportional to 1 upon M, and here A1 is directly proportional to 1 upon small m. If small m is lesser, what will be the value of acceleration? Acceleration will be higher. And if, see, here you can see the acceleration is higher. And as mass is higher, here mass is higher. For higher mass, the acceleration is lesser. The lesser the acceleration, difficult to pull the wagon. Okay, so when you see there is any kind of wagon going on which is having a very large mass, they always got stuck or their velocity used to be very slow. You can pick up an example of a truck which is loaded very heavily and it is overburdened. Then after some time you can see that the truck is it is very difficult for a truck to pull on. Okay, you might have seen many a times it happen that whenever we have a trolley, tractor and trolley, for that trolley if that got overloaded, many a times this happens, the tractor will going to swing like this. It's above vehicle at the front wheels, I can say front tires will go upward. The position of particular truck is just like tractor is like this, just like this. Should we pull off the particular trolley because it is heavily loaded. Okay, it is very difficult for the tractor to load it, to pull it down. Okay, so yes, we can say that mass, acceleration and force, they are interrelated with each other. How come? By Newton's second law. And if there is a Newton's second law, then how are they related? The acceleration is directly proportional to the force applied. Larger the force, higher will be the acceleration, but irrespective of constant mass. If there is a larger mass, the acceleration caused by the body will be less. Mass is high, acceleration will be low. Mass is low, acceleration will be very high. So this is all about how you can understand the Newton's second law. And for understanding it in a better way, I think we should pick up a numerical. So who will going to help me out in sorting out a numerical, guys? Will you going to help me out? All right. So there is a question. Calculate the resultant force on a sprinter of 80 kg who accelerate at 8 meter per second per sec square. Okay, that's sec square. I should make it correct. Okay, guys. So they have said calculate the resultant force on a sprinter of mass 80 kg who accelerate at 8 meter per sec square. Okay, so what are the parameters we have? Yes, guys, what are the parameters do we have? We have mass, that is 80 kg. All right. What else do we have? We have acceleration of the body. Mass is 80 kg and acceleration of a body is 8 meter per sec square. Firstly, let us understand what is the question. Calculate the resultant force on a sprinter of mass 80 kg who accelerate at 8 meter per sec square. That means if sprinter is moving, okay, so we with an acceleration of 8 meter per square, which is having a mass of 80 kg, what will be the resultant force acting on that particular sprinter? So yes, we got the answer for it. We know according to Newton's second law, force is directly proportional to mass and is directly proportional to acceleration. Is that right? Acceleration is equals to F upon m. We should write it like this as we have understood it. Okay, acceleration is directly proportional to mass, of course, and it is inversely proportional to mass of the body. Or we can say that force is equals to mass into acceleration. And what is the mass of the body? It's around 80 kg. And what is the acceleration of the body? 8 meter per sec square. So, what will be the resultant force? Force equivalent to 8 into 8, that is 64 into 10, that is 640. 640 kilograms meter. I should write it in a better way, otherwise my student is going to consider the unit as different. Kilogram meter per sec square. Okay, so what this kilogram meter per sec square called as? This unit is defined by Sir Newton only, and which is called as 640 Newton. We know that this is the unit of force applied. Okay, F is 640 Newton. So yes, if sprinter is moving, sprinter of 80 kg is accelerating at 8 meter per sec square, then the resultant force applied on it should be of 640 Newton. That means 80 into 8, mass into acceleration. I have another question related to it, which is called as uh, mass we got as 800 kilogram. Calculate the acceleration of car. We need to calculate the value of acceleration. All right. And mass is given as 800 kilogram of a car on a acted on by a resultant force. What is the resultant force acted on the car is 3200 Newton. We have applied a force of 3200 Newton on a car which is of 100 kg of mass. What will be the acceleration on that particular body? Let's calculate it. We know that acceleration is directly proportional to force, inversely proportional to mass. And there you go. Force is 3200 Newton per 800. 8 into 4, that will be 32. 4 meter per sec square, that will be the acceleration acting on the body. One more question. If in case that car of 800 kilogram got loaded with a mass of 300 kilograms, now what? Suppose the person who was sitting in that car are of 80 kg mass, okay, and they must be, or I should say they are of, we are not concerned about it. Suppose they are of 6 people are there, and that is of 60 kg mass, so that must be 360. Okay, so this is the mass of the car, this is the mass of the person who was sitting on this car. Now, what will be the resultant force acting on that body, or resultant acceleration acting on that body? We can say that what is the acceleration? Acceleration will be equivalent to force upon mass, and we can see that the mass has been increased now. The new mass is around, force is 3200 Newton, and mass was earlier it was 800, and right now it is 3600. So what is my resultant mass is? That is 360, sorry, 360. So just 3200 on 0, 6, 8 and 3, 11. So now the mass has been increased, guys. Now let me know what will be the effect on that. What will be the effect on this particular car, acceleration of this car? How will it vary? Now the acceleration on this body is reduced. Acceleration on this body has been reduced to 2.758 meter per sec square. Now the acceleration has been reduced. The car won't be able to accelerate as it was doing earlier, such kind of heavy mass. All right. So thank you guys. This is for today. This is for today's lecture. For the next lecture, be in continuation with me for the next session. Thank you everyone. All the best.